Welcome back students to the lecture series of Introduction to Analytical Chemistry. So let's get started. In this session we are going to discuss about significant figures. The number of scientific figure is the meaningful digit which are known with certainty. The uncertainty is specified by writing uncertain as well as certain digits. For example, if you take 57.4 is the number in which 57 is certain and 0.4 is uncertainty in measurement which are associated with the numbers. So now we see the concise form of the rules for counting significant figures for the zeros. There are the three types of the zero. For first type is the leading zeros. So leading zero is never count. So here you see 0.0079, in that these are the leading zeros which are not count. Hence 7 and 9, these are the only two non-zero digits we consider. Hence for this we have the two significant figures. Next type of the zero is the captive zeros, which are always count. Captive zeros are present in between the two non-zeros digits. That here, for example, we take 1.005. In that 1 and 5, are the non-zeros digits, and in between the zeros are present, we have to consider. So for this we have the four significant figures. And third type is the trailing zeros, which are count only if the number is written with decimal point. For example, in 200, only one significant figure we have to consider, because these two zeros are not with the decimal point. Next is this 200.0 something is there. Okay, so these zero are we have to consider, and because they are with the decimal point. Hence we have three significant for this, and 350.0 for this we have to consider four significant figures. This is a very concise form. Now we discuss the rules for the deciding significant figures. So rule first, all non-zero digits are the significants. For example, 138.957 contain 6 significant figures, which are 1, 3, 8, 9, 5 and 7, because they are the non-zeros digits. Rule number second, zeros between non-zero digits are significant. For example, 120.007 contains 6 significant figures, because these zeros are come in between the two non-zero digits, that is 2 and 7. Rule number 3, the zeros on the left of the first non-zero digits are not significant, such as 0 indicates the position of the decimal point. For example, 0.00232, in that we have to consider only three significant number, that is 2, 3 and this 2. Second example we have take 0.005, in that only one significant number is there, that is the 5. Next example is the 0.095, in that two significant numbers, that is 9 and 5. Rule number 4, in numbers written in scientific notation, all digits are the significant. For example, 2.035 into 10 raised to 2. This is the scientific notation, and we have four significant number for this, that is 2, 0, 3 and 5. Next example is the 3.25 into 10 raised to minus 5. For this we have to consider 5 significant numbers. Next rule, zeros after the decimal point at the end or on the right side of the number are all the significant. For example, 0.500 have the three significant numbers. These two zeros which are present at the right hand side of the decimal point we have to consider. Second example is the 0.400. It had again three significant number, because these two zeros are present at the right hand side of the decimal point. 4.0 into 10 raised to 2, this is again the scientific notation. Hence we have two significant number for this, because 4 and this 0 are the two significant numbers we have to consider. Here three significant number, 4 and these two zeros. In 400 gram only you have to consider one significant number, because the trailing zeros do not count as significant. Note that trailing zeros with decimal point count as significant. Now we see how many significant figures in each of the following. For example, first example we have to consider 1.0070. In that these two zeros are present in between two non-zero digits, that is 1 and 7. Hence we have considered for 5 significant numbers. Here 17.10, in that 4 significant numbers we have to consider, because this 0 present at the right hand side of the decimal point. In that these two zeros are present in between two non-zero digits, that is 1 and 8, and we have to consider for the counting these two zeros, and this 0 again we have to consider, because this 0 is present at the right hand side of the decimal point. Hence for this we have 6 significant numbers. 3.29 into 10 raised to 3, this is the scientific notation. Okay, so for this 3, 2 and 9 you have to consider, so 3 significant numbers for this. Here again 4.065, again this 0 is came in between the two non-zero digits, that is 4 and 6, hence we have the 4 significant numbers. Here 0.32, in that two significant numbers, that is 3 and 2. Again here scientific notation, and 0 is present at the right hand side, hence we have the two significant numbers. Here 0 is present right hand side, two zeros, hence we have to consider, hence we have for this 7 significant numbers. 45.26 are the 4 significant numbers, and here this 0 we have not considered, this 0 we consider because it is present in between the two non-zero digits. Hence we have the 3 significant numbers, that is 1, 0 and 9. Now it's your turn. Please pause this video and try to solve these examples and find out how many significant numbers are there. Okay, check it out your answers. First for this 2 significant number, for second 5 significant number, for third 3 significant number, for fourth 3 significant number, and last for 2 significant numbers. Now we see about the calculation with significant figures. In that we see the rounding off. It is very necessary because of precision and perfection. This method is also important because if we do direct calculations, such as if you consider 8.00 into 362 into 5.01274, this calculation will be complicated. If we round off, that is 8.00362 is equal to 8, and for 5.01274 is equal to 5, then now the calculation will be easy. That's why we round off the figures during the calculations. Now we see the rules for rounding off a number to the required number of significant figures. Rule number 1, if the digit following the last digit to be kept is less than 5, for example 46.32 rounded off to 2 significant figure, that is 46. Rule number 2, if the digit following the last digit to be kept is 5 or more, the last digit to be kept is increased by 1. For example, 52.87 becomes 52.9, and then we have 3 significant figures. Now we see if the last digit is 5, there are the 2 criteria, right? So if the last number before 5 is odd, then increase by 1. For example, 4.55, this 5 is the last 5, and before that this 5 is present, which is odd. Okay, so we have this 5 plus 1, 6 we have to consider, so it becomes 4.6. But if the last number before 5 is even, then just drop it. For example, 4.45, in that last digit is the 5, okay, but before that 5 even number is there, so you have to drop this 5, so it becomes 4.4. So lastly we see the round off each of the following to the number of significant digit indicated. So for that 1.23 to we have to change into 2 digits. So it becomes 1.2. For 12.56 we have to consider only 3 digits, then it becomes 12.6. If we have 122.17 and you want to 4 digit for this, then it becomes 122.2. For this again 231.5, we have 3 digit number, that is 232. Thank you.